Once again, good morning, everyone, and welcome back to another exciting day in mathematics. Warm-up 36 is on the screen. Once again, we are experts at this. It shouldn't take us longer than 5 minutes by now. Is that correct? Yeah, we got this. Once again, standard deviation and bell curve. 5, 9, 8, 11, and 15. Give you 5 minutes. Go. All right. My bell curve. All right, we need a mean. Let's see. Let's start with M. How about melody? What'd you get for the mean, melody? 9.6. Hands if you got that. That's correct. Then we go 1 standard deviation up, 1 standard deviation down. Now let's find our standard deviation. We need a standard deviation, sigma with an S. Standard deviation. Let's go with Levi. 3.3 approximately. Hands if you got something like that. All right, so therefore we are at 12.9 on the up and 6.3 on the other side. So my norm, by now we know that it's from 6.3 to 12.9. Turn to your neighbor, let them know something about this data according to that norm. What do you know about that data according to that norm? Levi, pass someone. Jordan. 2 out of the norm, which ones? 5 and 15 not out of the norm, that is correct. All right. All right, copy the agenda, please. Whoa. There it is, warm-up 36 is done. Frequency tables and graphs. Today we're moving on with more graphs since we already mastered the 3 graphs that we've been working on. And tonight's home place from pages 90 and 91. You're going to do numbers 1 through 10 evens only. However, I did include the pictures of the problems in this presentation. I'll give you the code in a little bit, just in case you don't want to go and dust off your textbook. Some of you are like, where is my textbook? Holding your door open. Okay, we good? Once again, warm-up 36 done. Frequency tables and graphs. Tonight's home plate pages 90, 91. Numbers 1 through 10 evens. Copy this code to access the home plate. KZ6X5. 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 Last night's home plate. One problem with an ogive. Go to Canvas, turn that in. I'm counting this as a pop party. If you have it. Should be titled 1 ogive, 1 distribution. Tonight's home plate looks like this. Those 4 problems. Let's go. All right. From there, get a Cornell note ready, please. Our objective for today can represent raw data into frequency tables and graphs. I can represent raw data into frequency tables and graphs. You sometimes turn your home plate in, get a Cornell go in, please. All right, here we go. So we're in the middle of frequency tables and graphs. And as I mentioned earlier, we already mastered 3 of the graphs that we've been working on. However, quick recap, we're still collecting data. There's 2 types of categories, categorical and quantitative. And another name for categorical, tell your neighbor another name for categorical. Qualitative, yes, that is correct. From there we went to frequency tables. We did simple ones, then all of a sudden we got into group distributions. Then we got into graphs, histograms, frequency polygons, and ogives. Yesterday we did another exercise with ogives. And I also mentioned when we covered those first three that histograms can be labeled in different ways like this. We have bell shape. You know what that looks like. Bimodal, where there's two spikes. Skewed left, that means that everything's moving to the right. That means there's a big gap on the left. Skewed right, everything's on the left. Big gap on the right. U-shape, obvious. And uniform, and where there's no actual pattern to it. It's all straightforward. All right? So yesterday we did a problem on IQs. You guys remember that? Yeah? And here's one of your colleagues that they turned in their ogive. Look at that. Look at the nails, though. What? They can poke someone's eyes out, something like that. All right? So, on your paper, write this right in the center of your paper, please, or at the top towards the center. Write graph. Today, I'm going to introduce 4 more graphs that we're going to be working on. First one, it's called the bar graph. Sketch that on the top left. Doesn't have to be exact, just so that you know what a bar graph looks like. On the top right, time series. Time series. Also, sketch that as best you can. And basically, it involves time and some sort of frequency, in this case, temperature. The other kind is pie graph. This is the most common one that is seen in newspapers or magazines. And Pareto chart. We'll talk about that. Even though it is a bar graph, where it looks like a histogram as well, this has a specific purpose by the way it's laid out. Let me send that to your screen. Okay, we good? All right, once again, it doesn't have to be exact, just as long as you have the 4 different ones. So, let's get started. We're going to start with bar graphs. So, on your paper, write example 1. Copy the table only, or this data. Example 1, on your paper, write that down. And it reads, the table shows the average money spent by first-year college students. Draw a horizontal and vertical bar graph for the data. So, just copy this. You don't have to copy all the verbatim. Write electronics, 728. Dorm decor, 344. Clothing, 141. And shoes, $72. This is going to go pretty fast, so stay focused. Here we go. To make a horizontal and a vertical bar graph, the very first thing when you get data, label one of the columns, label it X, and the other one is going to be our what? Y. Now that we have it labeled, now we can get our quadrant going. Here's our X. Here's our Y. So our X is electronics, dorm, decor, clothing, and shoes. Our Y is money. It goes all the way up to 728. I'm just going to go by hundreds. Is that okay? 100, 200, 300, 400, 500, 600, 700, 800. All right? So, electronics, how much was spent? 728. 728 is somewhere over here. Dorm decor, 344, that's between 300 and 400, so about right here. Clothing is 141, so somewhere right here. And shoes, $72. There you go. Now, do the bars have to be like close together? No. So this is called a vertical, a vertical bar graph. All right, next. To make a horizontal one, look up. Look up, please. To make a horizontal, all we have to do is switch the variables. So now the first column is our y, and the second column is our what? X. So label that underneath, and let's make a new quadrant. So now the x is by hundreds. And over here we label our stuff. We got electronics. We got dorm decor. Dorm decor. We got clothing. And lastly, shoes. All right, let me see. Let me start with electronics, the 728. So it's about over here. Bless you. Dorm decor, 340. So dorm decor, 340, about right there. Clothing, 141. 141. And shoes, $72. And this is called horizontal bar graph. From 1 to 5, I'll come to you with horizontal and vertical bar graphs. Where are we at? From 1 to 5? 5, 5, 5, okay. All right, send me your graphs. I want to see them. As you're sending that in, another way that they represent using bar graphs, have you seen something like this on the newspaper or internet? Yeah, right? When they compare 2 or 3 different things, they can use bar graphs such as that. Okay? Just wanted to show you a different way that they use them. All right? Next, copy this table onto your paper, please. Example number 2. Turn your paper over. Example 2. Copy the table only. Categories: juvenile complaint, loud noise, music party, drug offenses, driving under the influence, disabled vehicle, and the numbers given are 92, 27, 79, 38, 65, and the problem goes as follows. The data shown here consists of the number of police calls for specific categories that a local municipality received in 2011. No, just the table. The data were obtained by the author. Draw and analyze a Pareto chart for the data. So the Pareto, if you notice when you copy the 4 different graphs, you saw that one of them, or the Pareto, looks like a bar graph. Is that correct? Yes, Mr. Q. So what's the difference from Pareto to any regular bar graph, Mr. Q? Well, let me show you. As soon as you hear the word Pareto, you take whatever data they give you and rewrite it. But we're going to rewrite it from greatest to least. So category, number. So what is our greatest frequency, guys, in there? 92. So I start with juvenile complaint. I'm just going to put JC. And that was what? 92. What would be my next one after that? If we're going from greatest to least. Adrian. 79. Very good. So that is drug offense. Drug offense. 79. So we got 92, 79. What's next, Adrian? Help him out, Moses. 65. All right, so I think I'm going to have to move Moses and Adrian to the front. Disabled vehicle. That's 65. And since seating arrangement's coming up pretty soon in a couple of weeks, so we're there. All right. So what would be our next one, Jacob? DUI 38. That is correct. 38. And of course the last one would be loud noise. All right, and that was what? 27. Okay. So with that said, create a quadrant on the side. All right, once again, this is our X, this is our Y. So we got JC, or juvenile complaint. Then we got drug offense. Then we got disabled vehicle. Then we got DUI. And last but not least, loud noises. And it goes all the way to 92. So I'm going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And of course the X is called category, the number of complaints. The Y is the number of complaints. All right, here we go. Juvenile complaint 92. 92 is up to over here. Drug offense 79. 79, close to 80. Disabled vehicle 65. DUI 38. And loud noises 27. Now I want you to take a seat back, look at the graph. What do you guys notice on this specific bar graph? What's so special about Pareto? Talk it over to your neighbor. What's so special about Pareto? From the greatest to least. That is correct. Draw an arrow right here in case you missed it, like that, so that you know that it's from greatest to least. Whenever they say Pareto, greatest to least. Now, why do we need this kind of graph? Because it's easier to identify whatever it is the category they're talking about. In this case, they're talking about complaints or calls to the police department with complaints. What was the most that people complained about? Juveniles, yeah. people going crazy out there. Or juveniles going crazy, yeah? Which is the least amount of complaints of their calls? Loud music, right? Or parties, all right. From 1 to 5, what comfortable are you with Pareto? Where are we at? 5 4s, 5 4s, okay. Let's go to the next one. Copy this table, example number 3. It says, draw and analyze a time series graph for the data. Copy the table only, please. It says the data shows the percentage of you as adults who smoke. Copy that table. Hurry up, hurry up, hurry up. We don't have time, people. Bless you. All right. So, again, this problem is about showing the percentage of adults who smoke. So, label your table, look up. The first row is our X, the second row is our Y. So now that we have that labeled, here we go. So our X starts from what year, everyone? 1970. So if we don't have any data before that, what do we do here? What do we do here, guys, if we don't have any more data before that? Put the wiggles, yes. And then we start with 1970. Go to 1980, 1990, 2000, 2010, 2020. And over here we're going to do percent. What's the lowest percent, people? 19. What's the highest? 37. Let's go by tens. All right. Here we go. 1970 is 37. 1970, 37, right there. 1980 is 33. 1990, 25. 2000 is 23, Michael Jordan. And 19 for 2010. Connect the points. And this is called a time series. From 1 to 5, we'll come to where you with time series. From 1 to 5, yeah, 5, all right. All right, send me your time series on the screen, please. Go. Another way of presenting it looks like this. When you compare two different types of data with a time series graph, there it is. And once again, you have years, you have percentages. And our last one, pie chart. This is my favorite one. All right, copy the table, please. Stay focused, because this is the one that some of you or some of my students in the past somehow had issues with. I don't know why. This is the one that's more straightforward than them all. You will need a calculator, though. So copy that. This is comparing snacks to the number of pounds and eaten during the Super Bowl. So it says, this frequency distribution shows the number of pounds of each snack food eaten during the Super Bowl. Construct a pie graph for the data. And thank you for being so attentive, because I might give you a pop party on this tomorrow. 4 graphs. Oh yeah, we got this, huh? Just don't tell the other people. Huh, Sophie? Part A. All right? So here we go. When you get to this one, to create a pie chart, we start off by making one column, and that leaves us at the end a second column to the right. Here we go. Once again, I don't know what's going on, but some of you are very distracted. I don't know when you get to these how you're going to do. This column we're going to write percent. This column we're going to write degree. All right. Let me zoom in a little bit more. I'm going to start with percent. Y'all ready? Here it goes. To find how much percent each of these categories are for the total, we need the total number of frequency. What is the total number of frequency here in millions? 30. So let's say I wanted to know what percentage was 11.2 million from the total. We do 11.2 divided by the total, which is what? 30. And then once you do that, at the end, we multiply the whole thing times 100 to find the percent. We multiply whatever we get from there times 100. But before I do that, calculators calculate. Give me that value first. What is it? 336. $27.37. 0.37. That's 11.2 divided by 30 is 0.37, but then at the end we multiply times what? 100 to make it into a percent. That means we move the decimal twice, so that gives us what? 37%. So, find me the percentages for the other ones, please. Let's see, 8.2 divided by 30. What'd you get? Let's go back here to Yozgard. What is it? 0.27 times 100. That gives us 27%. All right. Next, 4.3 divided by 30. Pass someone, Yozgard. 14. So it's 0.14 times 100. That gives us 14%. Then we got 3.8 divided by 30. Pass someone. 3.8 divided by 30. What is it? 0.12. 0.12 times 100, and that gives us 12%. Hands if you got that. All right. And the last one, 2.5 divided by 30. We're going to go back here to Adrian again. Let's see what he's got. 2.5 times 30. 0.8. 0.8. Hands if you got 0.8. 0.08 times 100, which is 8%. Hands if you got something like that. All right. We got percentages, but now we need what? Degree. Now, percent, 100% is the whole pie. Is that correct? However, how much is degrees? Well, degrees is by how many degrees? Tell your neighbor, The whole pie is how many degrees? Yeah, 360. So guess what? We do the same process, but instead of multiplying times 100 for degree, we multiply times what? 360. So let's do 11.2 divided by 30. That was 0.37 times 360. That gives us a degree. Adrian, pass someone. Who? $130 what? 33.2 degrees. All right, let's go to the next one. 8.2 divided by 30 is 0.27 times 360. Pass someone. 97 point what? 2 degrees. Next one, 4.3 divided by 30 gives us 0.14 times 360. Pass someone. Geo. What is it? 50? Yeah. 50.4. All right, next one is 3.8 divided by 30, which is 0.12 times 360. Pass someone. 43.2 degrees. Sam, let's go. No hesitation. And then 2.5 divided by 30 was 0.08 times 360. Sam, pass someone. Who? Oh, 28.8. 28.8. All right. So, now that we have our degrees, can we break up a pie with that? Yes. Let me zoom out. Here we go. Make a circle on the side as best as you can. Let's go with all right, here we go. So, start with the first category, which is 132 degrees. What's that? I just did right now. What? Thank you. Appreciate it. Yeah, be nice. All right, here we go. So, kind of guesstimate. Look up, please. If we start here and we go, look up. If we go up to here, that's 90 degrees. Is that correct? So if I go halfway of that, let's say about right here, that's 45 degrees plus 90, that's 130 something, yes? So erase this. That's going to be, what was the food category for that? Potato chips. Potato chips. Potato chips. And what is the percentage? 37%. Go to the next category. Next category is tortilla chips. Tortilla chips is 97 degrees. So check this out. If I go down here, straight down, that's 90. Yeah? Like right here. But if I go a little bit to the left and erase that one, what's that? It's 98? Oh, my bad. Let me go a little bit less. Tortilla chips. And that one was 97. Oh, my bad. That was 27%. 27%. All right. Not bad, not bad. Let's go to the next one. Next one is pretzels. Pretzels is 50 degrees. 50 degrees. So 50 degrees, let's see, this was, let's see, if I go straight like this, halfway we say it's 45. 45 is about right here, a little bit more, about right there. Ever see what I did? So this is pretzels. Pretzels. And that one was 14%. 14%. Focus, please. Be nice. Then we got 43%. And I'm going to go with this little space right here. 40, because this was 40 something, so I'm going to go with, what was that? That was popcorn. And that was 12%. And this little piece right here, we're going to make the last one. Last category was snack nuts. Snack nuts, and that was 8%. What's that? Yeah, we're using the degree to draw the piece, but we're labeling it with percent. Once again, we're using the degree to draw our piece, but when we label it with percent. Yes. Say that again? Yeah, the one you wrote down? What? All right. From 1 to 5, we'll come through you with pie charts. Where are we at? 4, 5, 4, 5. Okay. Those of you that are following on YouTube, make sure you put some work in. And I'll see you guys next time. Peace.